interesting things is that you can just divide the two equations, and if you divide these two equations, this unusual factor will be ignored or removed. So you will get 1 omega 2 df d omega 2 equal 1 omega 1 df d omega 1. The right hand side of the equation is the function of omega 1. The left hand side is function of the omega. So you can use the separation of the variable parameter. I use the as a separation of the variable. We are very lucky that we have the separation of variable, but not always we can use that. There are a few cases there are many cases that you cannot solve the system by the separation of the variable. Also, it depends on the coordinate. For example, the simplest equation called the Laplace equation in electromagnetism cannot be always be separated in the variable. You can do that only in the 14 coordinate system. Around the 14 you know just 3, I think. Cylindrical and spherical and flat. But there is a 14 coordinate system. You can make it the separation of variable for Laplace equation.
From there it should be 1 over omega 2, or it is omega 2 df by d omega 2.
1 over omega, yes.
Yeah,
that's right. Yes. So it will be omega 1, that's yes, thank you. Yes. So it means that you needed to make everything wrong. So df d omega 1 will become. So from here you get f is car integral d omega 1 over omega 1. So you get car ln omega 1 plus some constant. And do the same for the omega 2. F omega will be car ln omega plus C0. And this is entropy. Without more physics, just by accepting the additivity conditions, you can get the functional form for the entropy for any system. So we obtained a very interesting equation is that car this equation can be understood as the delta S also. You can relate that to the entropy S0, and you can say that delta S is S minus S0 car in omega. How you want. But it's very easy to show that the C0 is 0, basically. If you have just one state, there is no change of the entropy for when you have just one state. You cannot make change to your system. You have one state, so all possibility is given just by one option. So even all have the same probability, statistical probability. So from here you can define something like probability to find a specific configuration for the system, which is 1 over omega also. Anyway, you can forget about the C0 and consider that at the 0. And S will be car ln. And this car eventually, by comparing with the thermodynamic, you can show that this is actually exactly the Boltzmann constant. 23 or 20, yeah. So that's all, and so we understood that the S can be written in the this. So if you give me the idea of the omega, I can give you the entropy. From the entropy, you can obtain all the thermodynamical parameters, like the pressure, like the total energy, like everything you can find in here. Just additivity here is hidden in this equation. So this equation still supports the additivity. If you have a system and the system is partitioned to the different parts like omega 1, omega 2, omega 3, any other possibility, omega 4. So the number of the possibility is given by the multiplicity or product of the all possibility. This is like the sigma, but is product symbol, product. So look at that bottom of the entropy. So S total will be K ln omega total will be K ln this. So this is, you needed to know that the ln pi will be pi anything sigma am. And any product is just sigma ln. ln. So it will be sigma and n each one. And that's you can write that. I told you, this all approach is the Gibbs approach. Equilibrium thermodynamic. There is some system, they obey different things, like the Sallis entropy expression. They are not additive, actually. There are some systems, their entropy is not additive. SAQ, for example, SAQ1, Q2 is SAQ1, SAQ2 plus or minus some extra term of the Q1 and Q2. So normally these systems are, such systems are considered out of the equilibrium. See, we are not interested in such systems. We always are looking for the system with, they support the additivity condition for the entropy. So I will stop it here. And the next week, next lecture, we will calculate the accessible state. I wanted to find omega for you for some systems. And that needs the quantum mechanics, so we will do that.